Ed, it's great to see you. I got to give you a lot of credit. Since the last time I saw you, May's done one thing. You've grown, you've grown, you've grown, and you've grown. Now you're in Japan. You've got this big focus in Japan. As our listeners and viewers know, I'm very, very bullish on Japan. Why such a large focus on the Japanese market?
Well, we have a lot of investors and partnerships in Japan, which is super helpful. Toyota is probably the one that most people know about. We've been working with Toyota, not just as investor relationship, but working on integrating our technology into Siennas and e-pallets and other unannounced Toyota vehicles. And so that relationship, we're working together on safety case, we're working on architecture, on the hardware, and bringing those vehicles to market. And so Toyota's been really helpful in terms of helping us get into the Japan market. And then this really accelerated with NTT. So NTT is our lead investor from our last round. And most people, I think of NTT as the Japanese, cell company. And yes, they do that. But they are also looking at a lot of the social problems in Japan, the driver shortage and aging population, and thinking about where can they have a great impact? And their answer to this is they want to become the leading mobility services provider in Japan. And the only way to do that with an aging population and a driver shortage is with autonomy. So now NTT is betting on May Mobility to provide autonomous technology for the Japan market. So we have two of the largest companies in Japan betting on May, really helping us navigate the political and regulatory environment in Japan. And I think we're in pole position to win the Japan market.
You have two great, iconic Japanese companies, and one of those is a global iconic company in Toyota. Are they betting on you because you understand the economics of autonomy, or are they betting on you because of May's technical abilities?
I think it's got to be a little bit of both. So, and I think they actually couple. I think we're on the commercial side. I think we've really demonstrated that May has always been really focused on building even since we started the company in 2017, within just a few months of launch, we had our first paying customer. This was always an important part for me of building the business, showing that there's a customer that's going to buy the darn thing. And all along the way, we've been building the business, finding a go-to-market strategy that makes sense, positive unit economics, primarily in the B2G space. And I think that is a level of practicality that they really appreciate. And that translates into the technology too. I think what a lot of companies see in the AV space are companies that have built some pretty impressive systems, but they scratch their head. At what cost? Some of those systems are incredibly expensive. They've had monstrously large teams, and they're not looking to replicate, $10 billion a year kind of burn rate. That's a little high, but billions of dollars a year of burn rate. They want to build a business that makes financial sense and in the next few years. And I think May checks those boxes.
You check those boxes, and I'll use a term. I like it. You have been extremely frugal as you're building your business, and I think it's smart because if you look at some of your competitors, they're burning $2, $3, $4 billion a year. And we're starting to see now the AV world divide where you're getting, it's called the smart money, like yourselves. They're saying, we want to build a business. We've always been like that. We want to build a business. And then on the other side, you're getting other companies saying, whatever, we're just going to burn money. Like we got 0% interest rates and JPal's got the bazooka out there. Where does this end up? Because if you look at the cost structure of these companies that are burning $2+ billion a year, I don't see any way when you run the numbers that they can become profitable until they hit 20, 30, 40,000 vehicles on the road. And even then, the margins are very slim, where I see a scenario where you could probably hit extreme profitability in under 2,500 vehicles just based on your cost structure.
Yeah, that's exactly right. So we project profitability on under 2,000 vehicles. And that's what you can do when you keep your burn rate really, really low. We actually benchmark some of the larger companies that because their central costs are so high, that it's probably more than a few tens of thousands of vehicles. It's probably hundreds of thousands of vehicles, especially in the B2C space where the revenue potential and margin potential is just not as good. And I think that raises the question of like, why are they burning so much capital? And I think a lot of this has to do with the way that they've built their technology stacks in the first place. One of the things that we've been thinking a lot about is, what makes a car intelligent? And, it's clear that there's a huge amount of feed forward intelligence that needs to go into any of these cars. So like by feed forward, I mean all the things like, your deep learning, your transformer models, your convolutional networks, your, all of those kinds of data driven systems. And those are hugely important. They're especially in the perception side, in prediction side, they can be it's hugely important. But one of the things that you hear a lot of the largest companies in the space say is that their strategic strength is that they collect millions of miles. And, I kind of like to poke the bear a little bit and be like, well, how many millions of miles did you need to see before you learned how to drive?
0.
Right, right. So, clearly something else is going on in a human brain that is not going on in these other systems. And the antidote, the shortcoming that they have is that their systems are not very data efficient. And so their recourse is to collect much, much more data, literally millions of miles, train even bigger feed forward models. And that requires an army of really, really, really smart people. And that's where the burn rate is coming from. And the problem is that that's not how humans drive. That's not how humans solve problems. There's actually I think when a human is in a new situation, we have the ability to kind of imagine what's going to happen next. So, most of the time when you're driving, like it's boring, right? You can carry on a conversation, you can be singing to the radio. If feed forward network is going to work 99% of the time, because it's just, you can drive reflexively. But what happens when you are in one of those really unusual situations? It's like garbage truck and a pedestrian. And we had a cool example the other day where the tree had fallen and there was a work crew wood chipping a tree in the middle of the road. So what happens when a human driver is there? Well, you're not relying on having seen that before. You have the ability to say, I think I know what's going on here. The pedestrian might cross the road. That construction worker might ask us to wait here for a bit. And you imagine the kinds of things that might happen next. And so you are able to handle situations that you've never seen before without having driven millions of miles to see a wood chipper in the road before. And that's exactly what we've been doing too with the multi-policy decision making. It's taking all of those feed forward models as a foundation, but adding on top of that the ability to imagine the things that might happen next.
You just don't want to see a wood chipper in Connecticut. That's a dark humor joke there, what that doctor did to his wife. I just don't want to see that there. Is there such thing as too big of a model where, I don't, I'm just going to use the human term, there's overload, where your brain like Wile E. Coyote and the smoke's coming out of it? Is there such thing as too big of a model?
Absolutely. So one of the challenges that you can have as a model gets really big is that it can learn wrong things. It can, overfit the data. So, there's a bunch of classic examples that if I give you, a few points and I ask you to fit a line to it, you're going to get a line. But if I give you a really big, complicated model where you can fit any function at all, then you can learn this bizarre, squiggly path that connects all the points. And so the problem with a really big model is that you can learn a model that overfits the data that you have. Now, what's the antidote for that? More data. To constrain the model more fully. And so the bigger you make the model, the more data you need to collect to train and constrain the behavior of that model. And that means bigger teams, but it also has a really negative impact on the bill of materials price of the vehicle itself. If you're training a really big model, you got a lot of flops. And that means more GPUs in the back seat. And that means more power consumption, more silicon that you're buying, more power dissipation. And for an EV, it means now you're sinking potentially kilowatts of power to run these oversized models. And the tragedy of all of this is that bigger models is not the answer, right? Again, it doesn't require driving millions of miles to learn how to drive if you can frame the problem the right way. In the same way, like how many times did you need to read the entire internet to write a limerick, right? So data is not always the complete answer. Data is wildly important, but it's not the complete answer. And actually, LLMs are kind of an interesting analog because today, the state of the art in large language models is not just the feed forward models. They all started with the transformers, like the GPTs of the world and the Olamas. Those are the feed forward networks. But what are you seeing today? You're seeing deliberative reasoning capabilities being added on top of those foundational models that get you things like ChatGPT o1, things that have an ability to handle much more difficult problems that are outside of the training data. That's exactly what we're doing in the autonomous driving space, giving the ability to the vehicle to handle situations it hasn't seen before.
Now I'm going to throw another ingredient in there. Sundar Pichai yesterday announced Google's Willow quantum chip. What does that do to the whole equation?
Yeah, so I'm not an expert in quantum computing for sure. But my understanding in the space is that the size of the computations that you can do today is pretty modest. You can factor a number as large as like 35 or something in that neighborhood. It's really interesting to imagine what would happen if you could, run Shor's algorithm at scale. But it's not clear to me that this is going to be a near-term game changer for autonomous vehicles, or that it's really necessary. That autonomous vehicles are really a conventional physics kind of problem. There is uncertainty involved, but it's not clear to me that there's a killer algorithm for quantum computers that will change autonomous driving. Could be wrong. It'd be fun to be wrong about that.
It'd be fun for all of us to be wrong. It'd be really interesting to see as Willow scales up, let's say a decade from now, what the breakthroughs. We'll have all the scientific papers. We'll have data sets to look at benchmarks. That's, I'll say, 5 to 10 years down the line. Today, most people are running the NVIDIA H100s. When you're building the May vehicles, you're very public with the Toyota Sennas. You have the e-Palette. How much onboard compute does it take to run those vehicles?
Yeah, it's a great question. So, a typical AV today will have multiple very high-end GPUs in the back or on the roof. And those are powering the perception system primarily. So you've got these large networks that were trained on large amounts of data by your large team of engineers, and then they're sucking away power in the back seat. And then they have a relatively light amount of CPU power on there. So it's mostly GPU, a little bit of CPU. An interesting thing about May Stack is that we actually flip that around quite significantly. We have GPUs, of course, because we're using a lot of the same underlying network architectures for our perception stack, but we keep those models much, much smaller. And instead, we have quite a lot more CPU power. Now, the reason we have CPU power is because this multi-policy decision-making, we're essentially doing Monte Carlo tree search as to explore this set of things that might happen in the future. And that's a very sequential task as opposed to a very parallel task. Now, it's embarrassingly parallel in that you can run multiple simulations in parallel on different CPUs, but within one particular simulation, it's a very sequential task, well suited to a CPU. And so our compute workload looks quite different than other AV stacks. Now, that's sort of a curiosity left to itself. But the interesting thing is that when you add up the total power consumption, we come out way ahead. So it turns out that if you have a technology like multi-policy decision-making under the hood, your vehicle is intrinsically able to handle uncertainty about what's going to happen. Imagine, for example, that your perception system is saying, hey, there's a pedestrian on the road. I think they're going to stay there, but there's a 10% chance that they're going to start walking across the road. If you have a traditional system, you're predicting trajectories for them, and then you're trying to compute a trajectory for the autonomous vehicle that's not going to hit any of the other trajectories. But if you're wrong about those trajectories, then you could be planning for your vehicle to be in a place where that pedestrian is going to be in the future. And so a lot of this traditional approach of building motion planners based on trajectory predictions is incredibly sensitive to the accuracy of those prediction models. So what do? Well, then we better make our prediction models as good as we can. We better build a bigger network. We better go collect more data. And you go around this loop a couple times, you end up with very, very large models to try to squeeze out every last % of performance you can out of your prediction system. In May Mobility System, we of course care about the accuracy of our prediction system, but sometimes due to free will or noise or whatever else, you may not know whether that pedestrian is going to step off the curb or not. So what do? We pick a policy for our vehicle that is safe under both situations. So we're explicitly considering both possibilities, and not just for that pedestrian, but how that pedestrian might interact with the garbage truck and how the garbage truck might change its behavior based on the traffic light, and rolling all of these scenarios out and picking a strategy that is safe, independent of which of these things happens to come next. That in turn means that the requirements for our perception system are lower. We can handle our perception system sometimes being wrong because we can plan under uncertainty.
How did you develop these policy decisions? Was it studying historical crash videos, incidents, police reports? How did you come up with these policy decision-making process?
Yeah, that turns out to be one of the hardest problems here. The MPDM stuff, some technologies, things that we've been working on for a decade. You can go and read our early papers on it. And, one of the things that you'll see in the papers is it sort of says, so you have a set of policies. Here's how you take that set of policies and turn it into a even better policy by doing online reinforcement learning. So it's basically multi-policy decision making is online reinforcement learning applied to a set of policies that have been validated offline. But your question is, where do those policies come from in the first place? This turns out to be a really interesting problem. So the challenge that you have is you have a trade-off. You, on one hand, you'd like a lot of different policies, because if you have a lot of policies to choose from, you've got a wider gamut of behavior that your vehicle could exhibit. That's going to be more flexibility, more ability to work its way out of a tricky situation. On the other hand, the more policies that you have coming into the system, that increases your computational requirements. So you need to find the happy balance between these. So we found that the sweet spot in here is maybe a dozen to 24 policies, somewhere in that. You can really have a large, diverse set of representative policies. With 12 policies can do a pretty good job of representing almost anything you'd want to be able to do at that given time. And then being able to choose between them gets you a nice combination of performance versus computational cost. But then that still leaves the question, but where did the policies come from? And so the challenge here is that you're going to have some policies that are the sort of thing that any undergraduate would think of. So follow the car in front of you, don't hit them. That is the standard policy. 99% of the time, we are stay in your lane, follow the car in front of you, don't hit them. But then the tricky thing is now you need other policies, which are sometimes going to be very bad choices. Maybe most of the time, they're not nearly as good as stay in your lane, don't hit the car in front of you. But every once in a while, doing something different is really, really great idea. And so that's what the rest of those policies are all about. How do you go and find those policies that most of the time are not a good idea, but every once in a while, that is exactly the kind of thing that you need to do. You need to make a lane change maneuver. Sometimes you need to pull out very aggressively at a traffic light because there's a car coming up behind you. You might need to trade comfort for safety. And so that's identifying those kinds of policies and then assembling that ensemble of policies turns out to be one of the hardest computational problems.
How do those policies change from America to Japan? I'm asking that because the cultures are a lot different between America and Japan.
Yeah, that's a great question. It's one of my favorite questions. So as you know, the behavior of a pedestrian in Detroit is quite different than a pedestrian in Tokyo. So in Detroit, or most of the United States, the driving pedestrian culture is more of a negotiation, a loose, flexible negotiation. Like, my car is a little bigger than yours. I'm a little bit more in the intersection. I think it's my turn, even if you have a green light, even if the pedestrian is a little walking man. And then sometimes pedestrians will kind of push and shove, and it's a war of assertion and almost dominance. In Detroit, I think it's even harder. I think the biggest vehicle has the right of way. So if you've got to Escalade, like they've got the right of way.
Or the snowplow. The snowplow comes, he's got the right of way. He's big.
That's right. In Japan, it's wildly different. In Japan, pedestrians are much more compliant. They're very unlikely to jaywalk. But at the same time, they are vastly more likely to be oblivious when they actually have the right of way. Like they'll be looking at their phone and they won't even look up. They will trust that all the other cars are going to wait for them. So they follow the rules themselves and they believe that other people are going to follow the rules in turn. Now, in the United States, if you did that, you just never get anywhere. So the question is, what was involved in getting our system to change its behavior from Detroit driving to Tokyo driving? And here's the challenge that comes back. If you've done this in a purely feed-forward network way, where you've trained up all of your models with millions of miles of data, and you go to such a radically different driving culture, guess what? You're going to have to go collect millions of miles more data and significantly retrain your model, which is going to cost you a huge amount of money. In our case, what we did was we went in and we relearned our model for pedestrian behavior. So we're able to reach into our simulator and say, actually pedestrians in this environment tend to be much more rule following. Probability that they're going to jaywalk is lower. The probability that they're going to move forward on a green light is much higher. From that change alone, you get a huge amount of emergent behavior out of our car. So if all of our simulations of what's going to happen show that the pedestrians are not likely to jaywalk, guess what? We accelerate more aggressively out of a green light automatically because we are more confident that the pedestrians are going to stay on the sidewalk. Likewise, if there's a pedestrian with the right of way and we model that they're just going to heedlessly move forward, we will yield to them. So we actually didn't have to change very much about our system at all to adapt to a very different driving culture. And I think in terms of AV companies, I think we might be you can tell me. I think we might be the only AV company that operates in such radically different driving cultures from the US to Japan. And we're in 10 cities in total, from big cities, little cities, coastal cities, Japan cities.
Cruise was testing with Honda before the untimely incident, but you are the most diversified from an environment perspective. You outside of the Chinese autonomous vehicle companies, and I say this with all due respect, there's no transparency, so I cannot give you clarity. I can give you public statements and documents on the environments that they're testing, but I can't give you my word to the audience. I can't validate necessarily what I'm reading is true. What I can validate is your documents. And yes, I would say you're operating in the most diverse environments. How many different cities or regions in Japan are you currently operating there? And then when you start to get into some of these sub-regions, and are there different cultures and customs in some of the regions? I ask because we all saw the unfortunate blowback, and this does not involve vehicles, in Kyoto this summer, where tourists were rude, they were disrespectful, and when they were interrupting with the Japanese culture, which was highly inappropriate, the Japanese government had to step in to try and correct that. So there are different cultures inside of Japan. How do you deal with those cultures, and where are you operating in Japan?
Yeah, so today we are operating in, it's hard for me to remember exactly which ones we are public. So I'll start with the ones that I'm sure are public.
How about you start with the ones that are not public? Then we'll do that.
Yeah, that's more spicy, isn't it?
Yes.
We're in Nagoya. We launched a service there just recently. So we're right by the train station. That's a fun route. We're also in Kyushu, so rural Japan. And that's where we have an e-pallet operating. And then we have, I'm not sure if these have launched, but we can follow up on it. But there are several areas in Tokyo that we have people on the ground. And I don't think we've launched them yet, but we will soon.
So you're interesting. So you have an environment. I'm assuming that's a commuter rail that you're close to. What type of rail is that?
I think it's near the Shinkansen.
Okay, so beautiful. You're near the rail. You're operating in a rural environment, which we'll get into with the age in place policies, and you're operating in a dense city environment. So you have the MPDM that you've developed. How does that change for all these different regions? Because they're vastly different. The train and the dense, they can be a lot closer, but rural in Japan, some of those roads are very narrow. And going back to customs, there's rules of the road that aren't necessarily written down, but from living there. How does your system adapt to these vast differentiating environments?
And that's the key thing. Like, we're just not that big of a company. We can't have, a 400 person Japan engineering team that's bigger than our entire company. We're shy of 300 people today. So the challenge is, how do you make this really scalable? And the good news is that the technology itself lowers the lift. So being able to imagine these different scenarios gives our vehicle a lot of ability to handle situations that are outside of our training data. So we've escaped this problem of having to collect all of the data so that our vehicle always knows what to do. But there are places where we need to go in and we need to refine models or adjust them, localize them to the local conditions. The pedestrian models in Tokyo is a great example. Roads tend to be a little narrower in Tokyo than, say, Arizona. And so there's a different comfort level that the vehicle needs to have with, how much are you going to slow down if you're driving past another vehicle at 2 feet versus, 4 feet. In Arizona, in like a Chandler where Waymo launched, or Sun City where we operate, both of those are driver out deployments. The roads are very wide. And so, the standard is that, like, you can usually make space between you and a pedestrian. And if you can't, then something weird's happening. You should probably slow down. In Tokyo, if you are passing within a couple feet of another car, so what? That's driving in Tokyo. So there are some adjustments that we have to make. But the key thing is that the amount of work and validation that goes into this is much, much less, because our vehicle is able to do this online learning and adapt to what it's seeing in situ.
The online learning, is that done in your simulator?
Yeah. So basically, MPDM is, I kind of glossed over what the technology is, but it's pretty interesting. The idea is that multi-policy decision-making is a form of reinforcement learning. So what the vehicle is doing as it's driving around is it takes the current situation that it sees and it generates new training data based on the situation it's in. And we have a simulator where we sample from our probability distribution of what we think other agents are going to do. And then we simulate forward 10, 20 seconds to see one possible version of what might happen next. Maybe the pedestrian jaywalks, maybe the garbage truck creeps forward 20 feet and stops. We play all that out. And then we do this about 1,000 times every second. So we're essentially creating new training data that's relevant to the situation that we're in. And then we label that in an unsupervised way. So all of those different simulations are rated in terms of, are they safe? Do they follow rules? Are they comfortable for the passenger? And then we use those now labeled training data as a reinforcement signal into our system to update our driving policy so that we can figure out how to better handle the situation that we're in. Now, the hard part here is doing all this fast enough so that you can learn something quickly enough and low enough latency that you can actually, that the situation is still the same, right? That the world hasn't changed out from underneath you. So this process of generating new training data, labeling it, doing reinforcement learning back to update our driving policy, this happens in about 200 milliseconds. So it's crazy, crazy fast. And that's what allows our vehicle to handle these new situations it's never seen, because in 200 milliseconds, it's seen it 1,000 times. You give our vehicle 200 milliseconds, it will have seen this thing hundreds to thousands of times.
MPDM is running on the edge in the various different vehicle platforms?
Yes. Yeah, this is all on vehicle. Doesn't require a cellular link back to the cloud. So a lot of what we have been working on for the last 7 years is figuring out, how do you make this run fast enough so that you can get probabilistically, useful information and run enough simulations.
What role does DRAM or RAM play in being able to get that time so low?
It's mostly CPU bound. So most of the simulations are not especially memory hungry, but they are very CPU hungry. And so that's kind of an interesting thing about our system, as I mentioned, that our compute workload is much more focused around CPU cores and running these Monte Carlo simulations than it is around just throwing data in a feed forward deep net.
Could you, in theory or technically, run that on the Qualcomm digital chassis or an ARM architecture?
Yeah, actually, our system regularly on ARM. All of our production vehicles are x86 CPUs today, but ARM cores are definitely interesting. And the nice thing about it is that, a sea of ARM cores is just about ideal for us. A sea of relatively, they don't need to be super high single threaded, performance CPUs.
And that's low power.
Low power is the name of the game. You mentioned when you're thinking about how are you going to scale this technology, even if you've got a vehicle that drives really well, if it's using kilowatts of power, it's just an anchor around your neck from a product perspective. First of all, the bill of materials is higher because you have to buy all that silicon. And that just means that like OEMs and people who want to deploy this kind of technology at scale, it's just not reasonable to expect them to put kilowatts of compute on board. I actually think that one of the next big challenges in the AV space is going to be a race to 100 watt 80K, level 4 80K. Now, nobody is anywhere close to that today, but we are much, much closer to that than anyone else in the space, as far as I'm aware. And I think that that's one of the things I'm really excited about. Can we continue to optimize our stack, push the power requirements down, and be able to put this on every vehicle that's ever made?
What happens when 100 watt 80K is achieved? What's unlocked?
So the cost is going to be a lot lower. If you're 100 watts, then you only have 100 watts worth of silicon. And that really opens up the possibility to putting this on every vehicle that's made.
Then you have a scalable business at the end of the day.
Yeah, we think we have a really nice scalable business even before that, that can scale to hundreds of thousands of cars in the next decade. But then if you want to talk about millions and put it on every vehicle, then you really need to shrink it down so that it's a 100 watt box that you can slide into the autonomy slot.
How are you planning to deploy the Mace service in Japan? Will NTT create a mobility app since they have the mobility aspirations, or will you create what's called the May Mobility app, May Mobility One? What are the plan for deploying your technology as you ramp up in scale in Japan?
Yeah, so our strategy has always been a little bit different than other companies that are chasing Robotaxi. We are not aspiring to be vertically integrated. So what we know we're really good at building the autonomy capability, but there's a whole bunch of components that need to come together to make a high quality mobility service out of that. It's not just the technology. You need, rider support, you need insurance products, you need boots on the ground, you need regulatory functions. Like all of those components need to come, and you need an app, right? To come to your example. And we don't feel like that those all need to be May services. In fact, we think that there are companies that have been working for decades, getting really good at things like fleet maintenance, fleet management, building mapping apps and ride hailing apps. And we're very happy to partner with them so that we can do what we do really well and they can do what they do really well and ultimately deliver a better product to our customers at a lower price point.
When you deploy in Japan, the e-pallet, is that going to be built on a Toyota factory line? And I'll be running the May software along with the May hardware specifications?
Yeah, so that's the vision that we're driving towards. So, ultimately today when the Siennas or e-pallets, they come to us and there's quite a lot of disassembly to put our wire harnesses and our sensors in it and then put it all back together. This is extremely wasteful for obvious reasons. So the vision ultimately is that we'll be able to pick up the phone and call up Toyota and say, "Hey, can you drop another, 300 vehicles off in Atlanta?" And then be able to provision them over the air so that May people never actually physically touch the vehicles. And partners on the ground would take care of the fleet maintenance. That to us is a really exciting scalability story. And it's one that we're already starting to make some steps to. So the vehicles that we are receiving now from Toyota, they don't integrate all of our sensors yet, but we are starting to introduce modifications on the Toyota side that reduce the total amount of labor. Keep doing this year over year, Kaizen, step by step. And ultimately that will lead to that path where we can just pick up the phone and get vehicles delivered into market for us.
Provision over the air. We got to walk down this. Atlanta, you have a public partnership with Lyft. Let's just say you call up Toyota, as you said, you drop off 300 Toyota May-powered vehicles. Let's just say they're in a parking lot. Then one of your engineering leads pushes an update to the vehicles and unlocks them. Is that how this is going to work?
Yeah, so imagine that we have a local operator, like a fleet management, the sort of company like the kind of companies that rental car agencies might evolve into. That, they've got boots on the ground, they've got a parking lot, they've got a staff to wipe down the vehicles. So a bunch of trucks roll up, the Siennas come out the back end or whatever the future platforms that we haven't announced yet with Toyota. And then the vehicles have cellular modems on them. And so, someone calls them up, they ask for a license to use our software, Autonomy software. We update them with the latest software, the latest maps for their region, and that's it. We're done.
That's a business, Ed. That's a business. There's no other way for me to describe it. That's a business. That is the most clear-cut example I've ever heard from an autonomy company and how you're going to scale a business. I like it because it's not, you don't have to go to the bank, you don't have to go to NTT, you don't have to go to Toyota for a loan. And the vehicles are not going to sit on your balance sheet. It's brilliant. Now, will you get a licensing fee per vehicle? Will you get a per mile fee? How do you see those economics work?
Yeah, so the crystal ball, there's a lot of different ways to structure this. My prediction is that it's probably going to be like a monthly or mile-based autonomy as a service fee. So there'd be the component of, hey, you are subscribed to our software service so that you get updates. Every time we make the vehicle handle a little, situations better or whatever the new feature is, you get the software subscription. And then also there's probably the live service monitoring so that, where there is remote assistance, you get the subscription for the vehicle to be supported by our remote monitors. Everything else, the rider support, the app, the maintenance, we're happy to, the insurance, we be very happy to help bring those partners to a customer. Or if the customer just wants to run with it, that's great.
I give a plug for my buddy Sergey over at Coop. If you need insurance, you call Sergey because he's got the largest book of business for autonomy. Because I see a future where your fleet management partner, if you're your fleet operator, it's all going to be bundled into some service for one fee. Because I feel that if you have to pay this vendor, this vendor, this vendor, this vendor, it gets really complicated. But if you pay one fee, it gets very, very simplified. What other services do you see potentially being added to this? Because if you look at the OTA over the air updates, you can unlock all sorts of fun things. You can push out the We're in the holidays now, so you can push out the Santa Claus edition where the screens inside the vehicle could have Santa Claus with Rudolph the Red-Nosed Reindeer. You can have a fireplace with a hot cocoa. What else do you see potentially being unlocked with these over-the-air updates?
Yeah, I think that there's a lot of opportunity to improve the rider experience. So, even setting aside the technology, I think one of the things, fast forward 10 years, there will be multiple autonomy stacks out there.
Mhm.
And so one of the things that we're already investing in is how do we make the rider experience really, really great? And that could be something like, hey, my kids are really excited about the Switch 2 coming out. So, could we have game playing stuff so that people could play a preview of the Switch 2 version of Zelda in the back of the car? Nintendo call me. That would be an amazing thing to do. Or even like, hey, every day you want your coffee, place your order in the for coffee while you're in the car, and so it's ready for you when you get dropped off at work. There's a lot of stuff we can do there to make that experience better. And part of the reason I want the rider experience is so important to me, and it's because I don't think success is just dropping 300 vehicles off in a new city. Because if the end solution is just replacing other people's congestion with our induced congestion, that's a bad answer for everything. The ultimate thing that May is really motivated by in terms of like a vision is how do we make riding a May vehicle just flat out better than driving yourself downtown? Because if we can do that, then we can start to have a positive impact on congestion. Maybe in some cases we can even coordinate trips, multimodal trips to mass transit so that you get a great ride to the local train station, and then the train station whizzes you downtown exactly to the central business district. But the challenge here is that we're competing against the idea of a multimodal trip versus hopping in your private metal bubble and driving yourself. And this is hard because people like driving their own personal little metal bubbles downtown. Even if you get stuck in traffic, it's still your space, you're in control. It's exactly you get to leave when you want to leave. But I think what we can do is we can make the experience in a May vehicle start to compete with that. First of all, I think the May vehicle, when you're driving an autonomous car, you get your time back, right? So you don't have to be driving, you don't have to be getting frustrated by it. But the real challenge in my mind is how do you make a multimodal trip compete with a personal driving yourself to work downtown? But I think there's an angle here which I don't hear a lot of people talking about, but I think it's huge. So today, you imagine a multimodal trip, and you're like, hard pass. Right. So, Ed, your proposal is that I'm going to hop in a car and I'm going to go to the train station, and then I'm going to take the train downtown, and it's going to take, we're going to go 800 meters. We're going to stop, and we're going to be 13 stops down, to where I'm going. That sounds like a nightmare versus just being able to be in one place, do your thing. Here's the killer change. Today, rail stations are very close together because they're designed around how large the basin of service is. How far away are they drawing ridership to a train station? And it's about 400 meters. It's about the maximum length of distance that someone's willing to walk to get on light rail. So what do you need? Well, now you need train stations about every 800 meters because you get 400 meters in both directions. And this means that your trip from suburbia downtown has 20 dang stops, and it takes forever because the train doesn't get up to high speed. What happens instead if instead of 400 meter funnel, you have a 3-kilometer funnel? Because you've got really great May vehicles that will get you from your house in a really comfortable vehicle. And now you get taken to one of those stops. Now the train has fewer stops and it can sustain a higher average speed. So now the total transit time from suburbia to your office downtown is like half of what it would take for you to drive yourself. Now you can start to compete. And I think this is the big opportunity, the thing that we're excited about. We want our technology in every vehicle. If you have to drive yourself, you should have a May technology stack making your vehicle safer. But in terms of making cities more beautiful and more accessible, I think that there's this end game, this act 3 in the autonomous saga, where cities embrace autonomy and it radically changes the way that people move around cities. And by partnering with cities today, we want to be the autonomous partner in pole position to help make that come to be.
I'm gonna let you in on a little secret, Ed. Nintendo executives listen and watch this podcast. So for the Nintendo executives that are listening, NTT, Japanese company, Toyota, Japanese company. Me being a big kid, I would love to get into May Mobility and play Mario Kart. How great would that be? I'm going in an autonomous May Mobility vehicle and I am playing Mario Kart. To answer your question, Ed, around the in vehicle commerce, I've had long discussions with MasterCard. MasterCard, believe it or not, does have a dedicated autonomous vehicle team, small team, but they're looking at in vehicle payments here. Visa has a team as well, but it's mostly focused on the transit side. That team's based in Miami. You're right about experiences. Nintendo, here's another pitch. Please make the Nintendo May Mobility car. If it's in Kyoto where you're based, I will fly over to Kyoto. I just want to test it. I don't have to be the first rider. I just really want to test it and experience this future. May Mobility is going to build the stack. You're going to build the driving functionality. Your partners are going to handle the logistics from a fleet maintenance, cleaning, the software of how you're going to handle it. Your processing partners are going to handle the compute. And then do you see that other layer, like kind of diving down even deeper into this, becoming the experience layer, whereas May ramps up perhaps in Kyoto, you have Nintendo. In Ann Arbor, perhaps you have the University of Michigan go blue during a football game. Do you see those different kind of experience layers depending on the markets where you're operating, or you're publicly in Atlanta? The Super Bowl's going there. Perhaps it's a Super Bowl experience vehicle. Do you see that layer evolving eventually?
Absolutely. I think it's really important for us to make the experience great. And what people want out of their car is going to depend on where they are, also depend on who they are. For me, for example, probably the best experience you could give me is to just quiet, please. I'm going to open my laptop and write code because that's what I do to relax. But someone else might be in a very, very different place. The end result is that, when in the future, when you pull out your phone and you're requesting transportation and all these little buttons start popping up. Oh, Waymo 1 is available, little blue circle. Oh, Cruise is available, red circle. And then the green circle for May pops up. We'll know we win when people are like, oh, hell yeah, green circle it is. That's what we need to create. And we want to get started with that as soon as possible.
You're getting started with the Japanese market. You're getting well established. And I publicly said this, and I'll publicly say it again on this podcast. I believe that becomes your largest market in the next 3 to 4 years in terms of revenue in fleet size. Point blank, saying it publicly again. Back here in America, you're expanding to Atlanta with Lyft. What does that expansion look like, and why did you pick Lyft? And I got to give a lot of credit. David Risher, CEO of Lyft, he listens to this podcast, and he's actually coming on a future episode. He's doing a really great job of turning the company around. Why did you partner with Lyft?
I think one of the things that we've been looking at in the journey in May is a travel through different business models. So today, our primary business model is a B2G model. So we're selling to governments, also some businesses in there. And there's some really great strengths to this market. When we sell a fleet of vehicles to cities, it's part of our vision of working with cities to make transit better. But there's also a contract in place, which for a startup provides a reliable source of revenue, a predictable cost structure. And on the strength of that contract, we can finance all of the vehicles. So we don't have to buy our vehicles out of equity dollars. It's a beautiful business. And the best thing about it, the cherry on the cake, is that the revenue potential is great. A typical city bus costs $150 an hour to operate. That's way more revenue than you can earn in the ride hail space. So that has been a really great place for us to grow our business. We'll continue to grow our business in that B2G segment because it's so close to our heart and so close to our vision, and it's a good business on top of it. But it does have one big shortcoming. And the problem with the B2G market is that it's fairly fragmented. Most of the cities in the United States might represent a 20, maybe 50 vehicle deal. Now, today, that's a great contract for us. But as we look to scale to thousands to tens of thousands and then even more vehicles, selling vehicles 10, 20 at a time is not a very efficient way for us to scale the business. The nice thing about plugging in with the partnership with Lyft is that it's our first foray in the B2C space that most people describe as the ride hail space. And this is exciting for us because when we think about our total demand, how much demand do we need from riders for us to deploy enough vehicles to become profitable? Well, it's quite a few cities, or it's one deal with Lyft. And so Lyft on its own represents enough potential demand for May to become not just profitable, but wildly successful. And so it's a path to scaling. And it's also one where we've worked a lot with the Lyft team, and we really like working with them. We think they have a shared vision about how to deploy the technology and how AV should be worked in there into these fleets. So we're really excited about it. This is a first step in the B2C space, but I think it's the first step into a really exciting high growth business market.
It's a positive step. Since David Risher's taken over Lyft, it's a completely different company. Mr. Risher, sir, you're doing a great job. Continue to do the wonderful job you're doing of executing and turning Lyft around. Will the main mobility vehicles operate in a robotaxi sense in the Lyft network in Atlanta, or is it going to operate more in your traditional fixed route model that you've historically had?
So we don't have any boots on the ground yet. So we're just getting started in Atlanta as we speak, which, by the way, we're going to spin up Atlanta in just a few months. So we're still on track to launch in 2025. So it gives you something about the speed with which we can work. The idea here, though, is that this is going to be like any Lyft experience. You use the Lyft app, you request a ride. If it falls within our service area, you'll get the option of picking a May ride, and then we take you there instead. And I think that our experience in other markets where there are both autonomous ride capabilities and human-driven rides is that people tend to very quickly prefer the autonomous ride. It's a consistency of product, of safety, comfortable ride, and oftentimes vehicles that are a trim level up and well professionally maintained. So I think it's really a killer product.
Autonomy offers what UberX or Lyft cannot offer: a consistent product. And we're seeing data now from the California Public Utilities Commission about how fast Waymo is growing in San Francisco. We're getting early data from the CUPC from Los Angeles, and everything that you and I agree with around the consistent experience is growing. 2025, you're launching with Lyft in Atlanta. Here's the ask. When you're launched, let's go record a podcast, you and I, in the back of a May Mobility vehicle driving around Atlanta. How's that sound?
That'd be amazing. Let's do it.
Awesome. So we're going to do that. And then I'm assuming first you're going to launch with safety drivers. And then is there a plan like you're doing in Ann Arbor and Sun City, eventually a roadmap when a certain metric is achieved that you will go fully autonomous in Atlanta?
Yeah, that's exactly right. This is a game book that we have played out of twice now, first in Sun City and then in Ann Arbor, to start with safety drivers, collect the data, go through our safety case. And when the data supports it, start operating without safety drivers. So we'll play out of the same playbook in Atlanta.
Well, is this where you'll introduce the fleet partner operator, where Toyota will drop off 300 vehicles to that partner so you're not holding that asset on your balance sheet? Will this be that first test market for you?
No, that industry doesn't exist yet. So, the main strategy has always been, when there's a gap in the market, we'll fill it. And so, that's a real challenge, that those partners that would operate hundreds of vehicles do not exist in the marketplace. Well, that's not entirely true, but we're actually talking to several of them right now. But the plan for Atlanta is that we will be operating this, and then ultimately we expect as it scales for us to bring partners in.
Is it fair to say that Atlanta with Lyft becomes your incubation market for this new model?
I think so. So, Atlanta represents just an enormous opportunity in terms of the demand and the scale. It's definitely the sort of place where, like, if you can make it in Atlanta, you can make it just about anywhere. It's a highly diverse in terms of high density, lower densities, lower speeds, higher speeds. It's got everything there. And so we see this as a really great way to start to become more visible to the general public, and not just the governments that we previously marketed to.
Atlanta's a great market. Atlanta has one thing, I think probably worse than LA, is traffic. The traffic in Atlanta, if you're trying to go from downtown Atlanta to Buckhead, is horrendous. The main way to get from downtown Atlanta to Buckhead is the freeway. Will you eventually work your way up to enable May on freeways?
Absolutely. We actually have our first freeway capable vehicle. It's being put together just a few meters over that way. But the challenge with freeways is maybe not what you think. Freeways are not hard from a complexity standpoint. In fact, you've got everyone's going the same way. It's divided. You have very few pedestrians. The challenge with freeways is just speed. And with speed, you need to be able to see farther. Today, the cost of the sensors to see far enough to operate well on a freeway make the vehicle unprofitable. And so it's not that we can't do it, it's just that we can't do it and make money off of it. So our strategy is to continue to wait for those sensor costs to come down. And when this becomes a viable business, will absolutely start freeway operations.
Do you see, is it perhaps a breakthrough in camera technology and the CMOS that's been pioneered by Sony that can allow it? Or is it, do you need a radar sensor? Do you need a long range LiDAR? What sensor is that you need to see the technological breakthrough and then the costs go, oh, plummet?
Yeah, so cost is definitely the big one. I would say that first of all, we don't have any religion on this. We're very pragmatic. If the best solution is radar and camera, we'll do radar camera. If the best solution is lidar and radar and no camera, I don't think that's likely. We'll do that. We're just how do you build a vehicle that's going to have the performance and the safety and the business case? If we can solve those, that's what we're going to do. But from a prediction standpoint, because predictions are more fun, I do think that it will be possible to operate a vehicle with cameras only around the end of the decade. I don't think anyone is ready to do that today and at an acceptable level of safety. But then I think the question is, it may be possible to do it camera only, but will it be best to do it camera only? And that I would not take as a given. So cameras themselves are cheap, but you pay for them on the backside with GPUs and flops. Whereas if there was if some of these very low cost lidars, China's seeing very, very low cost lidars, if a cheap lidar can eliminate some of the flops, you might end up with a system that has better overall performance at a lower price point, even though you have a lidar in there. That's not the case today because lidars tend to be more expensive, but it could very well be the case. So our strategy there is basically to build the system that makes the most sense from the technical, safety, and commercial perspective, whatever that is.
That's why you're running a business. The cost of LiDAR is coming down. We've seen it with Asai, and in March next year, the CEO of Asai is coming on to share their public 2025 roadmap of where they're looking to go. Atlanta, we talked about an immense amount of traffic. I believe it is either the world's busiest airport or one of the world's most busy airport in Hartsfield, Jackson. That place is a wowzerville. You got to go on the train to get around that that place. Being here in Florida, it seems like all flights go through Atlanta from when it comes to change. At some point, regulatory environment makes sense. The technology makes sense. Will you look to expand to the airport? Because to me, that's the big value unlock.
Yeah, I think airport trips are a significant source of demand. A lot of people are trying to get to and from the airport. So you can expect that we'll be looking for airport opportunities.
I said this earlier, Ed, May's come a long way. And I'm proud of you. I believe he's your first investor, one of your earliest investors, Mr. Riley Brennan from Trucks VC. He's been very bullish on you since day one, and he's very proud of you. I can't wait to see where you're going in the future because I know it's going to be a bright future. Ed, in your opinion, what is the future of May Mobility?
Well, I've always kind of jokingly thought about the stage of the company in sort of three phases. There's the phase that we started off with where, I as the CEO would be able to, of course, rattle off every city that we're operating in. When it was only 2 or 3 cities that we were in, it was always easy to do that. Like, oh, we're in Detroit and Ann Arbor. That's the list. Today, we're already in the second phase, which was wonderful, where I actually have a hard time rattling off the names of all the cities that we're in. It's like, it takes me, if you ask me to list all 16 cities, it would probably take me several minutes and a sheet of paper to figure out like which all of them are. And to me, that's just a wonderful indication of the growth of the company and the scale of it. And it's really exciting to be there. The future is where we're just everywhere. And when I might travel to a city and, I reach out for transportation, I book a ride, and then I'm genuinely surprised when it's a May vehicle that shows up in front of me, right? Because I just forgot that there was May vehicles in that city or in that area. And to me, it's seeing the technology in the wild, seeing it everywhere, and then seeing the positive impact that can have on cities, as cities might become more walkable, and you can start to reclaim some of those lanes of traffic and allow the restaurants to spill out onto the sidewalk. That's part of the future in terms of scale and impact that I think everyone at May that's why we're here.
May is growing. May will continue to grow as we turn the page to 2025 and beyond. The future is bright. The future is autonomous. The future is May Mobility. Ed, thank you as always for coming on the road to autonomy.
Thank you so much.